So today we're going to be talking about exponential functions in general. Today is our introduction to them. And so by the end of the lesson, you should be able to say that I can determine whether a function is exponential, evaluate that function, and graph that function. And so for warm-up today, what I want you to do is go ahead and graph this linear equation that we have here. I want you to graph it by making a t-table, because that's how we're going to graph our exponential functions. And so this is just a review about how we set up and construct t-tables, basically. So go ahead, give that a try, come back and check your answers. And so if you look at my work here, notice that when I found my y values in my t-table, I did all the work, and I showed each step of my thinking. And now with linear equations, that's not as challenging for us necessarily, but with exponential equations now, this is going to be super important to show all of our work with each part of our table, just to make sure that we will get the correct answer. Then notice when I graphed my equation, I put on my dots on, and then I connected my dots. Because this is linear, it's a nice straight line. Today with exponential, they're going to be curved, which you'll see later. So to begin, we need to talk about what an exponential function is. Well, an exponential function has the form y times equals a times bx. It says a cannot be 0, b has to be greater than 0, and b cannot equal 1. And then x is going to be a real number, not imaginary. And so everything we deal with today is going to be a true exponential function, and we're going to get more into our stipulations of what a and b can and cannot be in the next few days when we talk more about exponential functions. But for now, we just need to know it has the form y equals a times b to the x. And so to start today, we're going to go ahead and graph an exponential function. Y equals 2 to the x. Notice with exponential functions, the x is an exponent. They kind of sound the same, and that's how I remember it. But it's still the same thing about how you set up your t-table. X and y, we pick out our 5 x values. I like -2, -1, 0, 1, and 2. And then it's just plugging in your x values into your equation. So for the first one, I would have 2 to the -2. And here's why we want to show all our work. Using our exponent rules, 2 to the -2 is 1 over 2 squared. And then I know that's 1/4. Now what I want you to do is go through and find these next 4 y values for our x values, and then come back and let's graph together. So once you have your table completed, now we need to go ahead and graph. Notice that when I numbered my graph, I really spaced it out. I did every 4 lines was one, so each line represents a quarter, and that's actually just going to make my graphing a little easier. So -2 1/4, -1 1/2, 0, 1, which is the standard placement, 1 2, and 2 4. Then when we go ahead and connect our dots, notice it has that curve. It's just really zoomed in. Now this next graph just shows the different types of exponential equations you can have. And remember, our generic form of an exponential equation is y equals a times b to the x. And we had some stipulations. But remember, we're going to get more into that the next day. But looking at these graphs, this first one, where it just curves up and it's above our x-axis, this is a growth function. And here, a is going to be bigger than 0, and b is going to be bigger than 1. Down in the bottom corner, we have this function that's going down, and that's a decay function. With decay functions, a is going to be greater than 0, but b is going to be somewhere between 0 and 1. We'll learn more about these two tomorrow. But then also, in the other two graphs, they're both below the x-axis, and so they're neither growth nor decay functions, but they are still exponential functions. which we need to remember. So if they're below our x-axis, they're not growth or decay, but they are exponential. On this next slide, we need to determine if it's a linear or exponential table, and then we have to write our equation. So I'm actually going to start with the one over on the right. So if we're looking at our change in x's and our change in y's, we'll notice that our x's are going up by 1, and our y's are going up by 2 each time, every time we're adding 2. When your y's increase by a function where you're adding, we know that's going to be linear. We've dealt with it in the past. From here, we can write our equation. Y equals, we know our slope is a 2 over 1, which is just 2x. And then we have to figure out our y-intercept. So if x would be 0, we know something plus 2 would have to equal 5. So our y-intercept would be 3. So y would equal 2x plus 3. We've done that before. Looking over at the left, though, our change in x's are still just going up by 1, so that hasn't changed at all. But looking at our y's, 3 to 9 would be plus 6, but 9 to 27 is definitely not plus 6. So we have to think about multiplication. 3 to 9 is times 3. 9 to 27 you would also times by 3, and 27 to 81 we times. When you multiply for your change, then it's going to be exponential. Okay? And so what we want to make sure with exponential graphs is our y-intercept, unless there's going to be an a value, it has to be at the point 0, 1. So we would go back to 0, but we have to think what times 3 is 3. Well, I know 1 times 3 is 3. So our exponential equation would be y equals, whatever this y is, that's your a value. So it'd be a 1 times, and then our base is going to be a 3, and our exponent will be an x. So whatever you multiply is going to be your base, and x is always our exponent with exponential functions. A is your y-intercept. Next, it's just evaluating the function, and we've done this before. Remember, f of x is simply represents a function, but you could also write it as a y. So we could say y equals 3 to the x. And we have to evaluate it when x equals 4. So we're going to change x to 4. Y equals 3 to the 4th. Y equals 81. Looking at the next example, we have f of x equals 0.5 times 4 to the x. So if we plug in 2, we get f of x equals 0.5 times 4 squared. Well, 4 squared is 8. 0.5 of 8 is half of 8, which is 4. And so we could say f of 2 equals 4. And that would be more official notation than if we switch it over to a y. Our next example today has us graph the function by creating a table of values. So it actually already gave us our t-table, which is nice. And now we need to plug in 0, 1, 2, and 3 into our function and see what we get for our f of x or y values. So remember, show every step. Go ahead, fill in the table, come back and check. So if you plug in your x values into our function, our corresponding y values are 1/3, 1, 3, and 9. And so what I'm going to do is I'm going to number my x's where every other line is worth 1. -1, -2, -3. But I'm going to number my y's by 1 just to make sure that it fits. So 1, 2, 3, and so on. So we have a point at 0, 1/3, which is about right there. We're going to have to estimate with the fractions. We have a point at 1, 1. We have a point at 2, 3. And at 3, 4, 5, 6, 7, 8, 3, 9. When we go ahead and connect our dots, we want to make sure that because it's an exponential function, it has a nice curve, but we never actually cross our x-axis. Okay, we're never going to cross that line at this point in our algebra career. So we want to make sure it just kind of levels out without crossing. Last but not least, we have a story problem, and I'm going to go ahead and annotate as I read this problem. So you invest $1,000 in a bank account, and your money triples every 7 years. Now they gave us a function that models our investment. I'm going to rewrite it just so we can see it more clearly. It says f of x equals 1,000 times 3 to the x. Notice the 1,000 is what we start with, and it triples, which is our b value, every 7 years. It says x is the number of tripling periods. And we want to know how much our money is going to be worth after 14 years. So it triples every 7 years. And that's one tripling period. So 14 years is how many tripling periods, because x is tripling periods. Well, 14 times 2, or 7 times 2 is 14. So it's actually 2 tripling periods. So our x value is going to be 2, because that's how many times our money tripled. It's not going to be 14, just so you make a note of that. So let's go ahead and plug in 2 into our function. So f of 2 tripling periods is 1,000 times 3 to the 2. Well, 3 squared is 9. So 1,000 times 9. Our money is going to be worth $9,000.